Welcome to Chemistry Revision on the Move. Basic bonding and structure. When we think of matter, we've got to think about the bonding, how the atoms are held together. But we must also consider the structure, in other words, how the arrangement of those bonds are within the totality of the material that we have. Because whilst the type of bonding will affect the chemical properties, the physical properties really are very much determined by the structure of the compounds that you have. So, when we talk about bonding, we're really talking about how the atoms stick together. It's not just a simple talking about describing where electrons go. We've got to also think about how they stick together. And all bonds stick together in exactly the same way. We're talking about electrostatic forces, opposite charges attracting. And it's those opposite charges, those positive and negative charges, that produce this bond. And it doesn't matter what type of bond that we have, we're always talking about electrostatic interactions. So, types of bonds. Very simply, we have strong, what I'll describe as strong chemical bonds, in other words, ionic, covalent and metallic. But alongside those, we also have what I can describe as weak intermolecular forces. Although it talks about intermolecular, between molecules, what we will find is that a lot of these forces occur in other sorts of bonding as well. But what we have basically is hydrogen bonding, dipole-dipole interactions, and van der Waals forces, sometimes called London dispersion forces as well. So, I've already said that in terms of physical properties, we've got to consider bonding and structure. So what kind of physical properties am I talking about? Well, melting and boiling point is important. If you have strong forces holding the whole of the structure together, then the melting and boiling points are going to be high. But if we have something that can be broken up easily, then we may find that the melting and boiling point is much lower. Solubility in water or other solvents. It's to do with the interactions between the molecules or the structure itself and the solvent. We've got to consider those sort of factors when we think about solubility. Viscosity. Some liquids are thicker than others. Why? Well, it's a lot to do with the type of structure that we have. Electrical conductivity. Again, why do some things conduct electricity? Why do some things not? Why do some things conduct electricity in particular states and not in others? So in terms of types of structure, we can break them down very simply into two different sorts. Now these are always generalizations, and we may get some overlap always. But very simply we can say, okay then, so we've got giant structures. Now with giant structures we have strong chemical bonds extending throughout the structure without a break. So we can follow those strong chemical bonds from the center of the material right to the edge of the material. And therefore, to melt our material, to make our particles able to move around freely, we're going to have to break many strong chemical bonds. Now that therefore means that the melting point is going to be high, because we're going to need to put a lot of energy in to break those strong chemical bonds. Simple molecular structures still have those strong chemical bonds, but they are confined within the molecules themselves. And when we melt a compound with a simple molecular structure, we do not break those strong chemical bonds. What we do is we break the weak intermolecular forces between the molecules themselves. And because they are much weaker than the strong chemical bonds, we find that the melting point is much lower. So giant structures, generally high melting points; simple molecular structures, low melting points. But notice both sorts of structures have strong chemical bonds within them, but we are not breaking those strong chemical bonds with simple molecular structures. We are breaking the weak intermolecular forces between the molecules themselves.